This is CPM Calculus Chapter 4, number 60. So we're asked to change the following limit of a Riemann sum into an integral expression. So we have a Riemann sum here using sigma notation, and this is calculating the estimated area. Well, it's exact because we're taking the number of rectangles and going to infinity, but it's calculating the area between our function and the x-axis from -2 to 1. So a quick sketch of what that's doing. Here's -2, here's 1, whatever our function looks like. It's calculating this area. Okay? So let's go ahead and change this into integral notation and then evaluate it with our graphing calculator to see what the area is. So a quick review, we know that the limit as n goes to infinity of our area Riemann sum, where we have some variable k0 to n minus 1 of delta x times f of delta x, right? And this is sub k. You can say sub k or you can say times k, like either way, right? Is equal to the integral of our function from our region here, f of x dx. Okay, so this is our definition. So what do we see here? Well, we have the limit as n goes to infinity, right? Those are there. We have the range from some small constant to some big number of rectangles, right? Because n is approaching infinity in both of these. We have delta x, and then our function is here. So what this is saying is this is equal to, right? And our boundaries starts at -1 and stops at 1, right? -2 to 1. And our function f of x, right, is going to be x to the power of 1/3 minus 4 dx. So this right here is the integral expression of this Riemann sum. Okay, so let's go ahead and evaluate this integral in our calculator. So if you take your calculator out and you go F3 and go down to integrate, number 2. Our function now is x to the power of 1/3 minus 4. Our variable with respect to x, starting with -2, going to 1, right? So I evaluate that. Busy. And that's exactly how I want it to look, and that's equal to -13.1399, right? And if you're concerned, don't be too concerned. You could even graph this to make sure that the area should be negative. So let's graph it just for fun. We have x to the power of 1/3 minus 4. Let's graph it here. And if you look at our graph between -2 and 1, it is below the x-axis, right? So our graph looks something like this. And so we're calculating this area here, which is -13.1399 units squared. And this right here is our integral expression. Okay? So that's going to end CPM Calculus Chapter 4, number 60.